Welcome to Frontiers of Technology, the podcast of the Inter-American Defense Board. In this episode, we will address the growing use of drones, as well as the technologies and systems developed to detect and neutralize them, the associated risks, and how drones have transformed airspace, also highlighting the ethical and legal challenges they pose. Join us for this new episode where we explore how anti-drone technologies with a multi-domain operations approach are redefining aviation safety. Follow us on social media and visit our website, available in the description of this podcast. To begin with, according to recent studies on multi-domain force structuring, drones represent ideal asymmetric threats for urban environments, zones of irregular conflict, and intelligence operations, which require flexible and coordinated responses. Anti-drone systems enable scalable responses without the need to deploy immediate lethal force. What started as a military tool has become a technology accessible to civilians, businesses, and non-state actors. In recent years, drones have evolved from simple recreational tools to key players in sectors such as agriculture, logistics, film, and defense. Its accessibility, autonomy, and cargo capacity have democratized airspace. But this technology transfer has also brought with it new risks: espionage, sabotage, smuggling, and targeted attacks. Today, anyone can buy a drone with a camera for less than $100. Sensing technologies. Detecting a drone before it poses a threat is the first step. Today's systems combine multiple technologies. The ESA radar is capable of tracking small objects in motion at low altitude. Radio frequency sensors intercept signals between the drone and its operator. Optical and infrared cameras allow visual identification, even in low visibility conditions. Acoustic sensors detect the characteristic hum of the rotors. What criteria are used to differentiate between a hostile drone and an authorized one in real time? And how are false positives minimized? The systems cross-reference data on signal, trajectory, drone type, and behavior. To minimize false positives, machine learning models are applied that recognize anomalous patterns and adjust their decisions in real time. Methods of neutralization. Once detected, the drone must be neutralized without causing collateral damage. There are three main approaches. Signal inhibition. The jammers jam GPS, Wi-Fi, and remote control, forcing the drone to land or lose control. Physical capture. Through nets launched from interceptor drones or ground systems. Directed energy. Lasers and microwaves that disable electronic components without physical impact. Each method has advantages and limitations. For example, jammers can interfere with other communications, and lasers require pinpoint accuracy. Multi-domain approach and the future of air defense. Multi-domain operations involve the simultaneous coordination of capabilities on land, air, sea, space, and cyberspace. Anti-drone systems have become an essential tool for protecting assets and operations in all of these domains. Air and land domain. Anti-drone systems protect troops, convoys, and bases from the ground against low-altitude air threats. Cyber domain. Many drones operate using radio frequency links, GPS, or Wi-Fi networks. Anti-drone systems can intercept signals, analyze protocols, and execute cyber attacks to neutralize drones. Integrate with AI networks to identify threats in real time. Space domain. Some anti-drone systems rely on surveillance satellites to track drone trajectories in remote or hard-to-reach areas. Interoperability and joint command. Modern anti-drone systems are designed to be integrated into joint defense networks, which allow encrypted data to be shared between air, land, and naval forces. These systems enable scalable, interoperable, and adaptable responses to hybrid conflicts and complex urban environments. In addition, artificial intelligence plays a crucial role. Trained algorithms analyze flight patterns, speed, altitude, and behavior to differentiate between authorized drones and potential threats. Drones evolve rapidly. There are already autonomous models capable of navigating without GPS, avoiding obstacles and modifying their route in real time. How are anti-drone systems adapting to the new generations of autonomous drones with evasion and navigation capabilities by artificial intelligence? Defense systems are incorporating predictive algorithms, neural networks, and behavioral simulations. Sensors are developed that detect active evasion and signalless navigation. In addition, they are integrated into wider networks, such as UTM systems, which are platforms designed to manage drone traffic in airspace in a safe, efficient, and automated way. They are critical for integrating unmanned aircraft into urban, industrial, and strategic environments without interfering with conventional aviation. Strategic applications. Anti-drone systems are applied in multiple sectors. Critical infrastructures. Airports, power plants, refineries. Military defense and public security. Protection of bases, convoys, political leaders. Mass events and the private sector. Concerts, stadiums, industrial facilities. Technical challenges and legal challenges. The implementation of these technologies is not without controversy. What are the main technical challenges and legal challenges faced by the implementation of anti-drone systems in densely populated urban environments? Technical challenges: interference with civil networks, accuracy in confined spaces, risk of collision with structures or people. Legal challenges: international aviation law and regulations, privacy, use of force, liability in case of damages. In this episode, we have analyzed how drones have transformed aviation security, making this domain more complex, more vulnerable, and contested. Anti-drone technologies don't just protect infrastructure. They protect the right to live without invisible threats. Anti-drone technologies and systems are closely related to multi-domain operations. These technologies are key to integrating air defense, cybersecurity, electronic intelligence, and territorial control in complex and simultaneous environments. Thank you very much for joining us. Don't miss our next podcast, which will cover organizational challenges for AI integration. Let's continue to explore the frontiers of technology. See you soon. Inter-American Defense Board, promoting and strengthening hemispheric confidence and security.